all the materials linked to this orthogonal polynomials sequence in Zico book and theorem. So we multiply now the weight function by absolute value 2x power 2 minus 1 over p. So here you will see that here we said real of p greater than minus 1. Here we will take only p greater than minus 1. So we multiply this weight function by 2x power 2 minus 1 to the p. This work is accepted under revision by PMH, Periodica Hungarica Mathematica, with Professor Mohammed and my PhD student Majid bin Abdullah. So in this work we only gave in the first time the new recurrence coefficient. This is a new result. But the editor-in-chief sent me a report of this paper saying that it needs a deep revision and so many things. So, the first time the paper was rejected. So I wrote an email to the editor-in-chief saying that the report doesn't mean any rejection, just a deep revision. So many things to change and so many things to ask. So he told me to resubmit the paper again. So it is a hint for you. Whenever you have no rejection, so you must write to the editor-in-chief. So the first, when we wrote firstly the paper, we gave only this new result. So the editor, the reviewers asked so many things. So he asked us the differential equation, he asked us the zeros of these polynomials, he asked us the electrostatic behavior of these zeros. He asked so many things that it is not our specialization. So just to tell you that this is the recurrence coefficient of Chebyshev polynomials. This is the generalized Gegenbauer polynomials for alpha equals beta equals minus half. And this is the new ones. So please note here that this is 1 over 2. And this is 1 over 2 in our new work. This is 1 over 2. This is 1 over 2. This is for p equals 0, 1 over 4. For p equals 0, 1 over 4. For p equals 0, 1 over 4. Even here, for p equals 0, 1 over 2. For p equals 0, 1 over 4, etc., etc. So these all are generalization. Please note this. I will talk about this later. So the referee asked us, I will not get details, but the referees told me to write the steps in English, like this. The referee is sent us a very beautiful report. And just to tell you that there are so many referees that are honest and that are very good. So in order to give explicit recurrence coefficient of monic polynomials, WN, we need 4 steps. So the symmetrization of the linear function associated with the function WP yields a linear function U associated to the function US defined by this, supported on 0, 1. Their corresponding orthogonal polynomial sequence, noted Pn, yields W2n of xpn x power 2. This is a symmetrization process. And W2n is xrn. So we would do the first affine change of variable y equals to s minus 1, which gives this. And then a change of variable z power 2, and then a second change affine variable would give this, and then a backwards process allows to deduce the expression of polynomials in terms of Jacobi polynomials. So when we gave the recurrence coefficient, the referee asks us to write this information and to give the relation of this Wn function of Jacobi polynomials. So we spent more than a month doing what the referee asked. So the first report, I have received 2 reports. I have wrote this orthogonality relation, and you wrote WP equals 1 because of normalization factor. WP1 equals 0, WP2 equals, this is the moment. So this is, it is easy because our weight is positive. Here it is not so easy. And here WP2, it means that we multiply here by x power 2. So we have here x power 2. I told that, I wrote in my paper WP2 equals 1 over 2, and the referee asked me to do the proof. Prove it. They didn't accept this. So that's why I am writing here just a little proof. Indeed, we write that this is WP. We do some transformation here. I mean it, you will see why, because I will speak about the no problem later. And all this doesn't work. X power 2 minus 1. So we do this change on variable and a kind of small operation, and then we find 1 using this expression. So this is a normalization factor, and it is right. So W2, it is more complicated. So here we add minus half and we add minus half. So we prove that this is equals 0, and this is the moment of order 1. So it gives, this is all this 1 because of this, and we have 1 over the 2. How to prove that this is 0? Just you will have a node function over minus 1, so it is 0. All this is very easy and very good. We have a chance that we have something else. You'll see later it is not as simple as it seems. So this is what the referee asked us. So I will send the correction shortly tomorrow or after tomorrow. So we found the expression of W for n function of Jacobi polynomials. This is W is 8x power 4 minus 8x power 2 plus 1. And W for n plus 2, it is a polynomial power 2 and a Jacobi polynomials, Pn. W is the same quantity. And here, just a sum of 2 polynomials. We couldn't do this under 1 polynomial of the Jacobi polynomials. If someone has an idea, it will be great that he helps us. Is it possible to find Jacobi polynomials linking these 2 expressions? And also for the same thing for n plus 3, it is the sum of 2 Jacobi polynomials. We couldn't do this directly in only 1 term of Jacobi polynomials. Then the other thing where the referee asked us is to talk about the zeros. The zeros. And after the zeros, he asked us the electrostatic zero. So this is some information about zeros. The zeros, we take the zeros of Jacobi polynomials, and we use this, just the roots of this quantity. That's why we have square root and square root, 2 square roots. Okay. Also, all this talking about zeros, and then. As I told you, the referee asked us so many information about the electrostatic interpretation of the zeros. So he wrote some references of Murad Ismail and Walter Banash. I have written to Walter Banash. He told me, just do it by yourself. I'm not specialized in this area, to be honest. So me and my friends spent so many times to read all these things, to study the interpretation of this theory. So now they accept paper, but you must suffer accept paper. So there's a kind of a potential V unique attained at the 0. So you must learn something on this stuff, and then we apply it directly in our situation. So Vx would be this expression using the logarithm, and then the second derivative. This is the theorem given by Murad Ismail, saying when we have the electrostatic interpretation of this 0. It must be concave. It must be convex, but here it is concave, and here it changes sign. So that is according to Majma'i, we cannot study the electrostatic of this. I hope that the referee accept this study. We have no other idea than this. If someone is specialized in this area, so he would be kind to help us in this direction. So this is it. So now we attack the new work. This is the new work. I have a paper working on now. So later, earlier we have spoke about 2x power 2 minus 1. So now I take 4x power 3 minus 3x to the p. So I am looking for orthogonal polynomials, orthogonal with respect to this weight. So first of all, the same thing. We have WP x power this, 1 over 2, and the WP x4 is 3 over 8 for any p greater than minus 1. All these are open problems. We cannot do the stuff that I spoke earlier. We cannot do a change of variable, you cannot do anything here. I couldn't do it. Even for P even. أنا عدد زوجي. For P زوجي, I couldn't do it. So if someone could do this integral goes to 0, or this integral goes giving 0, it would be grateful for me. So, and pay attention, for all p, and here you have absolute value. So, what is asked here? Just, I take the big question though. So here, integral minus 1, x power 2 minus 1 over 2, absolute x power 3 minus 3 over 4. غاديك فما 4 مش مشكلة نعمل x to the p over square root 1 minus 2. The x equals 0. And this is should be true for all p. What does this mean? This is mean that this should be equal minus 1, x power 2 minus x power 3 minus 3 over 4x to the 5. Why I choose 5? You can choose anything. How to put this? This means that this integral does not depend on. I couldn't do it. For p even, for p odd, I couldn't do it. I asked all my colleagues in Qassim University, this is just a simple integral, do it. They don't, I will do it. So they start working, they never gave me a transfer until today.
But are you sure this equals 0?
Yes.
Why?
You can check with math. Take p equals 1, 2, 3, they check it every year. Whenever you give p.
But make will give us approximation.
No. Here is 0. To be honest with you, I just found an idea how to prove it for p even. I didn't finish this.
But it should be possible for p equals 0, as you said.
Huh?
It should be possible. For
No. For p equals 0, this is the moment of order 2 of this. This is true. حتى الأخرى زادت x power 4 should take the second integral. Minus 1, x4 minus 3 over 8. 3 over 8. X power 3 or 3 over 4x to the p over square root of 1. The x equals 0 for all p. For all p, or either real of p greater than minus 1, or for all p greater than minus 1 for convergence. For this vertical because the roots of this quantity are inside the support maximum. Let's say here it is equal x power 4 minus 3 over 8 over square root 5 minus x power 0 is would be because the moment of order 4 of this weight function is equal to 3 over. So they also you have to prove that the gamma n's, the recurrence coefficient, which I spoke earlier, is the this is what you call sale. Sale, it means the upper integer part. It means what? The integer part 1.5 is 2, the upper. To integer part. This is the upper integer part. And this is for p. For p equals minus 1, this is 0. For p greater than 1. So, and for all gamma 5 equals 1 over 4, gamma 2 equals 1 over 4. The gamma 4, the gamma 2, 5, 8 are all cancelled out. So, if we split all together, you see, this is 1 over 2, here 1 over 2, here 1 over 2, 1 over 4. So we can conjecture something here. We take a polynomial of order 2. They gave me, this is doesn't change. Now we take, everything is under conjecture. Huh? I didn't prove anything. So here we take a polynomial of order 3. So here the two quantities are the same. So if I take a polynomial of order 4, but take care, not any polynomials, special polynomials. You would define for this four polynomials 1 over 2, 1 over 4, 1 over 4. And then you take a polynomial of order 6, they would give this and this and this and this. And if you take a polynomial of order 1000, so you will find the first 1000 the recurrence coefficient of Chebyshev, and the other would change function of p. But this is a conjecture. If someone is ready to collaborate or to work in, I am just stuck on حاسب بالعربي, stuck on this for 3 polynomial of order 3. I didn't do it. I couldn't do it. I am not speaking about order 4, order 5, order 6, order 1000. I am speaking about this. You have 3 open orders. Okay. Just here I have some papers and some collaborators: Martinez, Marcelin, Little John, Jean Zhang. So all people, these people, I work with them. And that's. Thank you very much for attention.
Thank you. Thank you very much. Are there any questions, please?
Maybe here to do some change of variable. Change of variable. To change this integral, of course, and to reduce it maybe to the moment theorem or moment problem for measuring. If this, then measure must be 0.
Okay, we can think about it.
Yes.
But I suggest maybe to use residue theorem.
I tried. I tried residue theorem. I tried direct calculus. I tried so many things, but I couldn't do it. It seems to be very easy. Very easy. It seems to be very easy, but I couldn't do it. I gave it to all my colleagues in Qassim University. I don't know, no, this is easier, we can do it in 5 minutes. And when they start working, they couldn't do it.
As I understand, there is no general result. One time you took model x in power p, and then 2x squared minus 1 in power.
Yes.
There is general
Yes,
results.
yes. This is
Not take a particular function, but some measure, for example, under some conditions.
This is where
started with particular case. It means
I am
that
looking
there
for
is no general result.
I am looking for very general cases. I would like to take a polynomial there of order t, and I want to prove that the first t recurrence coefficient does not change and then change after.
I mean weighted functions. Yani weighted functions. Don't take special weighted function, but some measure under some conditions. This type results exist or not?
I have no idea. I have no idea. Just you see the first case, x power 2 minus 1 over 2, it takes me so hard to work with the referee. This is a special case, x power 2 minus 1 over 2 to the p. فما بالك now x power 3 minus 3 over 4x. It is a polynomial of order c. So he has 3 roots in the interval minus 1, 1.
This is my question. Why you choose this polynomial in this form? I mean,
أحسنت.
why this?
I am waiting for this question. These polynomials are themselves the Chebyshev polynomials. هذاك T3. هذا T3. والآخر اللي حكيته قبل شوية هو T2. Very good question.
I mean, you cannot,
أنا هو جاي من نفسه.
I mean, you cannot deal with other form.
No.
Why?
Well, I tried other. I tried U2. It is the Chebyshev polynomials of the first of the second kind. It doesn't match. Yes.
That means if you change 3 over 4 by something else.
لا, I didn't find any good result, explicit recurrence coefficient, etc.
Then you have to explain this fact. There is no possible, another possible choice.
Good question. I tried only Chebyshev polynomials of the second kind because they are the most beautiful polynomials. I didn't try any polynomials.
If you take Gegenbauer polynomials, you have to take another function here, yes?
I don't understand. The generalized Gegenbauer, you must take 8x only for generalized Gegenbauer. Only x. Yes, it is a T1. Okay.
Maybe in the work of Marshall,
Yes.
we consider this cubic chain, x cubed minus is called cubic, and under this chain, the interval of the support of the measure is not any interval. Is some because there are some solution. This equation has three branches.
Yes.
So three interval in the complex plane. So maybe this problem is you consider the interval minus 1, 1. So maybe it's not the good interval.
Maybe.
So we consider the problem in the general form.
Good question.
Why I ask this one?
Yeah, the solution of this
If you
equation.
change your variable, the interval will change.
I tried.
The solution of this equation
Couldn't.
is not x is not real. There are the three branch.
Yes.
It's not interval AB, only interval AB. Three kind.
Please, what are the motivations and the applications?
Very good, Ahsan. Very good. Now the physician or physicist, I don't know, physicists maybe هم أطباء. أيوة. They need the positive weight. Whenever you send a paper with not positive weight, they reject it. Right? So all what we consider here are positive weights. Again, this is the first fact. The second fact that the Chebyshev polynomials are always used in physics, chemistry, and quantum mechanics, and every branch. So whenever you have now a new parameter p whenever this p goes to 0, you find the Chebyshev problem. So they may use it for a more general problem in their own fields. So this is what I can imagine.
In the same way, here you consider the problem of electrostatic equilibrium of some charge counterpart, and the equilibrium position of this charge are the zeros of the.
Exactly.
Yes, this fact is related to Jacobi polynomials,
أحسن.
every classical polynomials. And also for the case of Chebyshev polynomials, famous result, big result in approximation theory, the zeros of the Chebyshev polynomials are when you do best approximation of continuous function in the interval -1, you take the Lagrange interpolation polynomial in the zeros of the Chebyshev polynomials. And here you consider the deformation of Chebyshev polynomials. What about the class of function? What about the class of function? And you get the same thing as the Chebyshev is.
I have no idea.
Because you do differentiation.
Professor Black.
Yes, I can give you an idea to solve this question. You can see this function, R function of P, but P has a complex number. And see the behavior of this function at infinity. If this function is bounded, for example, or I don't know, but
Yes, good.
so perhaps this function will be constant and
Good.
this function.
And whenever it is constant, so we choose p equals 0 and we find the result. Maybe. Good idea. Good.
More question?
تفضل نبي كيف؟
This is integral. If you substitute x equal tan theta, sin theta.
ايه would point this. Don't forget
Now, in case p equals 0.
لا properly equals 0 is known. This is known, very known. But this is how the problem is here. They very known. This is the moment of order 4 is 3/8. This is very known. But this is that my problem is x power t minus 3/4 x power p. For all p, you determine this one. How this integral